Hello everybody. We're going to be reviewing how to find the area and perimeter of rectangles, triangles, parallelograms, and circles, which with circles, of course, is circumference. The first shape, a rectangle, we take the either the top or the bottom of the figure we call the base, or represented by the letter B, multiply that times the height, or 5. Now the height generally is how far you would fall if you jumped off the figure. So in this case, the base times the height is times 5, or 50. And you would write that as area equals 50 units squared, because area is measured in units squared. To find the perimeter of a rectangle, add up all the outside sides, which involves adding this, because there's 2 of each side, you can multiply 2 times the base plus the height, which is multiplying 2 times base and 2 times height. Or you could write it as length and width. Doesn't matter what label them, as long as you cover both sides. Also, you can just describe it as adding the length and the length and the width and the width. So for this particular figure, it would be 10 plus 10 plus 5 plus 5 if we were to do it the third way. And if you add the 10s and add the 5s, it's 20 and 10. Makes 30. So the perimeter of the figure would be 30 units. And it's measured in length, not units squared, because it's the distance. Also, if you do it 2 times the length plus the width, it ends up being 2 times 15, which comes up with 32. So either way works, whichever you like doing best. On to triangles. For triangles, the area is also base times height, but there's something different about it. After you multiply the base and height, you divide by 2. You can write that as a fraction, base times height over 2, or you can write it all in a row, base times height divided by 2. Or, the third way you can write it is by multiplying everything by 1/2. So a half times base times height. Whenever you don't see anything between 2 numbers or 2 letters, it's probably multiplication. So between that 1/2 and the B is multiplication. So the area of this figure would be 5 times 10 divided by 2, because 5 is the base and 10 is the height. 10 is how far you would fall if you jumped off of the triangle. So if we write it as a fraction, it's 50 over 2, which 50 divided by 2 is 25. Or simplifying it down would be 25 over 1, which is just 25 units squared. Again, area measured in units squared. Also, you could just find half of one of the measurements, half of 10 or half of 5, and then multiply the base and height. 10 is easier to divide in half, so half of 10 is 5. So when we multiply half of 10 and the base, we get 25. It comes up with the same answer. So whether you multiply the numbers and divide by 2, or divide one of the numbers by 2 and then multiply, you'll come out with the same number, which is kind of fun about triangles. For perimeter, you just add up all the outside sides. Every triangle has 3 sides, so you add side plus side plus side. In this triangle, the 2 top sides are 7 and 7, and the base is 5. Adding those together gives you 19. We don't use the height for the perimeter of a triangle, because if you were going to walk around the perimeter of that triangle, you wouldn't walk straight through the middle. And that's the case with every shape. You don't use height, ever, in perimeter. No, no, no. On to parallelograms. The fantastic thing about parallelograms is that they're just like rectangles, only they've been knocked into and tilted a little bit. So the area is base times height, same as rectangles. For this particular parallelogram, the base is 5, knowing that the top and bottom are the same number, and the height is 10. That's how far you would fall, or where a rock would go if you dropped from the top. So 5 times 10 comes in 50. You do not cut this in half, because it's not half of a rectangle. The reason that works for triangles is because if you took a triangle and doubled it, and flipped one of them, you could make a rectangle out of every triangle. Every triangle is half of a rectangle with the same base and height. You don't cut parallelograms in half because its area is similar to a rectangle. For the perimeter of a parallelogram, it's pretty easy. You add up all the outside sides. It's the same as with a rectangle. You can say base plus side, or in this case, 5 plus 5 plus 7 plus 7. Now the only difference between a parallelogram and a rectangle is that in a rectangle you use a height. In a parallelogram you'll notice it's base plus side plus side. You don't use the height because it's not on the outside. In this case it would be 10 plus 14 equals 24. You don't use the height for the perimeter. Again, ever, never use the height for the perimeter. Unless it's a rectangle, I guess that would work. In this particular instance, the height is illustrated by a man standing at the top. And you'll have to excuse my mistake here. Of course, I'm human. Everybody's human. What is height? Height is this man standing right here, moving around with all the numbers. And this is me trying to move the man to show you him jumping off. And then I decide that maybe I should just have the man throw a rock down. So, the man takes a rock and he throws it down. And that's where it falls. That's where the height is. Or where you would fall if you were doing parkour or something fun like that. So that's parallelograms. In circles, there's this magical thing called pi. So finding the area of a circle is pi times the radius squared, which the radius is from the center out to the edge. The diameter is 2 radiuses, or radii. The diameter is from one side of the circle all the way to the other. Again, the way to remember finding the area of a circle is radius, pi times radius squared. It's squared because area is measured in units squared. That's how you can remember. The actual way we get pi times radius, or pi r squared, is by taking the circle, cutting it into triangles, and making a parallelogram. This piece in height multiplied ends up being pi times radius. Pi equals 3.14. That's an approximation. The equal sign should be an approximate sign because it goes on forever and ever. But for our purposes, we do 3.14 for pi most of the time. So pi r squared, in this case where the radius is 10, 3.14 times 10 squared, we always do the exponents first because of PEMDAS. And in this case 10 squared equals 100, so we multiply 3.14 times 100. And the handy thing about multiplying by tens and hundreds is you just count the zeros, and then that's how many times you move the decimal in the other number. So we move the decimal twice because there are 2 zeros in the 100. So 3.14 becomes 314. Pretty easy peasy lemon squeezy. And so area for this circle is 314 units squared. Now let's make some room for the circumference of the circle. Oh yes, the circumference of a circle. Now it's going to have pi in it again, or 3.14, because everything that has to do with a circle pretty much involves pi. Pi's are round, so why not have the Greek letter pi in every single equation for a circle? Now, the circumference is pi times diameter. That number gives us the radius, which radius plus the radius equals the diameter. So in this circle, 10 plus 10 equals 20. The diameter is 20. Don't forget to do that. That's the hardest thing to remember about circles. Once you get pi in there, do you use radius or diameter, and is it squared or not? Just remember, radius is always squared in the formulas, and diameter isn't. So in this circle, it's 3.14 times 20, and we can multiply 3.14 times 2, and then since there's 1 0, we move the decimal once. Whenever you have a number, when you're multiplying by a number with added zeros on the end, you can ignore the zeros and then just move the decimal later. Oops, look, I made a mistake. Can you guess what it is? Yes. 3.14 times 2 is 6.28. Move the decimal once, it's 62.8 is the circumference of a circle. Congratulations, you've done it. I hope this is a useful way for you to remember finding the area and perimeter of all these shapes.